in the given network the value of C so that the equivalent capacitance between A and B is 1 microfarad should be option A 32 by 23 microfarad, option B 23 by 32 microfarad, option C 3 by 2 microfarad, option D 2 by 3 microfarad. Correct answer option A 32 by 23 microfarad. Two capacitors C1 equal to 2 microfarad and C2 equal to 8 microfarad are connected in series across a 300 volt source. Then option A, the charge on each capacitor is 4.8 into 10 raised to the power minus 4 Coulomb. Option B, the potential difference across C1 is 60 volt. Option C, the potential difference across C2 is 240 volt. Option D, the energy stored in the system is 7.2 into 10 raised to the power minus 2 joules. Correct answer option A. The charge on each capacitor is 4.8 into 10 raised to the power minus 4 Coulomb. And option D. The energy stored in the system is 7.2 into 10 raised to the power minus 2 joules. A parallel plate capacitor of capacitance 100 microfarad is charged to 500 volt. The plate separation is then reduced to half its original value. Then option A, the potential on the capacitor becomes 1000 volt. Option B, the potential on the capacitor becomes 250 volt. Option C, the change in stored energy is 3.75 into 10 raised to the power minus 5 joules. Option D, the change in stored energy is 6.25 into 10 raised to the power minus 6 joule. Correct answer option B. The potential on the capacitor becomes 250 volt. And option D, the charge in stored energy is 6.25 into 10 raised to the power minus 6 joules. A parallel plate capacitor with air between the plates is charged to a potential difference of volt and then insulated. A plastic plate is inserted between the plates, filling the whole gap. The potential difference between the plates now becomes 75 volt. The dielectric constant of plastic is option A 10 by 3, option B 5, option C 20 by 3, option D 10. Correct answer option C 20 by 3. A parallel plate capacitor with a slab of dielectric constant 3 filling the whole space between the plates is charged to a certain potential and isolated. Then the slab is drawn out and another slab of equal thickness but dielectric constant 2 is introduced between the plates. The ratio of the energy stored in the capacitor later to that stored initially is option A 2:3, option B 3:2, option C 4:9, option D 9:4. Correct answer option B 3:2. Two slabs of the same dimensions having dielectric constants K1 and K2 completely fill the space between the plates of a parallel plate capacitor as shown in the figure. If C is the original capacitance of the capacitor, the new capacitance is option A K1 plus K2 by 2 into C, option B 2 K1 K2 upon K1 plus K2 into C, option C K1 plus K2 into C, option D K1 K2 upon K1 plus K2 into C. Correct answer option A K1 plus K2 by 2 into C. Two slabs of the same dimensions having dielectric constant K1 and K2 completely fill the space between the plates of a parallel plate capacitor as shown in figure 24.54. If C is the original capacitance of the capacitor, the new capacitance is option A K1 plus K2 by 2 into C, option B 2 K1 K2 upon K1 plus K2 by 2 C, option C K1 plus K2 into C, option D K1 K2 upon K1 plus K2 into C. Correct answer option B. 2 K1 K2 upon K1 plus K2 into C. A system of three parallel plates, each of area A, are separated by distances D1 and D2 as shown. The space between them is filled with dielectric of permittivities epsilon 1 and epsilon 2. The permittivity of free space is epsilon naught. The equivalent capacitance of the system is option A, epsilon 1 epsilon 2 A upon epsilon 2 D1 plus epsilon 1 D2. Option B, epsilon 1 epsilon 2 epsilon naught A upon epsilon 1 D1 plus epsilon 2 D2. Option C, epsilon naught A upon epsilon 1 D1 plus epsilon 2 D2. Option D, epsilon naught A upon epsilon 1 D2 plus epsilon 2 D1. Correct answer, option A, epsilon 1 epsilon 2 A upon epsilon 2 D1 plus epsilon 1 D2. The figure shows two identical parallel plate capacitors connected to a battery with switch S closed. The switch is now opened and the free space between the plates of the capacitor is filled with a dielectric of constant 3. The ratio of the total energy stored in both capacitors after and before the introduction of the dielectric is option A 5 by 3, option B 3 by 5, option C 5 by 2, option D 2 by 5. Correct answer option A 5 by 3. A parallel plate capacitor is connected to a battery. The quantities charge, voltage, electric field and energy associated with this capacitor are given by Q0, V0, E0 and U0 respectively. A dielectric slab is now introduced to fill the space between the plates with the battery still in connection. The corresponding quantities now given by Q, V, E and U are related to the previous ones as option A, Q greater than Q0, option B, V greater than V0, option C, E greater than E0, option D, U greater than U0. Correct answer option A, Q greater than Q0 and D, U greater than U0. Two identical thin rings, each of radius capital R meters, are coaxially placed at a distance capital R meters apart. If Q1 Coulomb and Q2 Coulomb are respectively the charges uniformly spread on the two rings, the work done in moving a charge small q Coulomb from the center of one ring to that of the other is option A 0, option B small q into Q1 minus Q2 into root 2 minus 1 upon 4 root 2 pi epsilon naught capital R. Option C, Q root 2 into Q1 plus Q2 upon 4 pi epsilon naught R. Option D, a small q into Q1 plus Q2 into root 2 plus 1 upon 4 root 2 pi epsilon naught capital R. Correct answer option B, small q into Q1 minus Q2 into root 2 minus 1 upon 4 root 2 pi epsilon naught R. A solid conducting sphere having a charge Q is surrounded by an uncharged concentric conducting hollow spherical shell. Let the potential difference between the surface of the solid sphere and that of the outer surface of the hollow shell be V. If the shell is now given a charge of minus 3Q, the new potential difference between the same two surfaces is option A V, option B 2V, option C 4V, option D minus 2V. Correct answer option A V. A particle A has charge plus Q and a particle B has charge plus 4Q, each having the same mass M. When allowed to fall from rest through the same electric potential difference, the ratio of the speed of A to that of B will be option A 2:1, option B 1:2, option C 4:1, option D 1:4. Correct answer option B 1:2. The work done in increasing the voltage across the plates of a capacitor from 5 volt to 10 volt is W. The work done in increasing the voltage from 10 volt to 15 volt will be option A W, option B 4W by 3, option C 5W by 3, option D 2W. Correct answer option C 5W by 3. A parallel plate capacitor with air between the plates has a capacitance of 10 microfarad. The capacitor is divided into two halves and filled with two media as shown in the figure, having dielectric constant K1 equal to 2 and K2 equal to 4. The capacitance of the system will now be option A 10 microfarad, option B 20 microfarad, option C 30 microfarad, option D 40 microfarad. Correct answer option C 30 microfarad. Three capacitors each of 1 microfarad are connected in parallel. To this combination, a fourth capacitor of 1 microfarad is connected in series. The equivalent capacitance of the system is option A 3 by 4 microfarad, option B 4 by 3 microfarad, option C 2 microfarad, option D 4 microfarad. Correct answer option A 3 by 4 microfarad. A parallel plate capacitor is charged and the charging battery is then disconnected. If the plates of the capacitor are moved further apart by means of insulating handles, option A, the charge on the capacitor increases. Option B, the voltage across the plates increases. Option C, the capacitance increases. Option D, the electrostatic energy stored in the capacitor increases. Correct answer option B. The electrostatic energy stored in the capacitor increases. A charge Q is placed at the center of the line joining two equal charge capital Q. The system of the three charges will be in equilibrium if a small q is equal to option A minus q by 2, option B minus q by 4, option C plus q by 4, option D plus q by 2. Correct answer option B minus q by 4. 7 capacitors, each of capacitance 2 microfarad, are to be connected in a configuration to obtain an effective capacitance of 10 by 11 microfarad. Which of the following combinations will achieve the desired result? Correct answer option A. A 5 microfarad capacitor is fully charged across a 12 volt battery. It is then disconnected from the battery and connected to an uncharged capacitor. If the voltage across the capacitor becomes 3 volt, the capacitance of the uncharged capacitor is option A 3 microfarad, option B 15 microfarad, option C 25 microfarad, option D 60 microfarad. Correct answer option B 15 microfarad. Two capacitors of capacitances 1 microfarad and 2 microfarad are connected in series across a potential difference of 6 volt. The ratio of the energies stored in them is option A 1:2, option B 2:1, option C 1:4, option D 4:1. Correct answer option B 2:1. A capacitor of 4 microfarad charged to 50 volt is connected to another capacitor of 2 microfarad charged to 100 volt. The total energy of the combination is option A 4 by 3 into 10 raised to the power minus 2 joules, option B 3 by 2 into 10 raised to the power minus 2 joules, option C 3 into 10 raised to the power minus 2 joules, option D 2.67 into 10 raised to the power minus 2 joules. Correct answer option A 4 by 3 into 10 raised to the power minus 2 joules. An infinite number of capacitors having capacitances 1 microfarad, 2 microfarad, 4 microfarad, 8 microfarad, and so on are connected in series. the equivalent capacitance of the system is option A infinite, option B 0.25 microfarad, option C 0.5 microfarad, option D 2 microfarad. Correct answer option C 0.5 microfarad. Three capacitors C1, C2 and C3 are connected to a battery as shown. With symbols having their usual meanings, the correct conditions are option A Q1 equal to Q2 equal to Q3 and V1 equal to V2 equal to V3 equal to V. Option B Q1 equal to Q2 plus Q3 and V equal to V1 plus V2 plus V3. Option C Q1 equal to Q2 plus Q3 and V equal to V1 plus V2. Option D Q2 equal to Q3 and V2 equal to V3. Correct answer option C Q1 equal to Q2 plus Q3 and V equal to V1 plus V2. Three capacitors C1, C2 and C3 are connected as shown. If the charges accumulated on the plates A, B, C, D, E and F are QA, QB, QC, QD, QE and QF respectively, then option A QB plus QD plus QF equal to 100 by 9 coulombs. Option B QB plus QD plus QF equal to 0. Option C QA plus QC plus QE equal to 50 coulomb. Option D QB equal to QD equal to QF. Correct answer option D QB equal to QD equal to QF.